Well done. Welcome, everyone, to the DeSci Labs forum. We're here to hear from Edvard about the DeSci Codex. I'm super thrilled because this is kind of the guts of what we're doing at DeSci Publish and DeSci Labs and DeSci Foundation. So excited to go. I'll pass it off to you.
Thank you, thank you. Yeah, first off, a little bit about me. My name is Edvard Hübinette. I'm a protocol architect and software engineer at DeSci Labs. Work mostly from Gothenburg in Sweden. And I want to start out sharing a little bit like why I am so interested in this space and why I'm so excited working in it. Basically, like our scientific progress that we do as a collection of human beings is sort of core to our progress through time, and getting to work on like safekeeping that constantly accumulating knowledge, I think is super cool. And being able to like think about and design methods of structuring and discovery of that information in ways that can help that progress and aid science in the long run, and allow us to like build the substrate for finding new ways to incentivize science. All right, so the big picture behind of what we're doing is sort of these points. Data discovery on the internet, super hard. Stable identifiers, super hard. Long-term data persistence, very hard. Like broken links, stuff you went to last week, everything is 404 today. Annoying, can't really do anything about it from that perspective. It's like fragile links, information really wants to get fragmented between like different locations, different services, and a larger and larger amount of the public data available relies on bigger and bigger central points of failure. All of the above makes the case of like safekeeping our collective knowledge, like we need to solve it basically. We need to have a stable way of handling all of those issues if we want to safekeep what we know through time and be able to build on it for maybe not, we can't think in time spans of like 5-10 years. We need to think in time spans of multiple decades, hundreds of years. And we can't do that with the system as it works today. So we have a mission today, all of us. We're going to explore the depth below our app, DeSci Nodes. We're going to learn what's actually happening like underneath the hood when you publish science on the CODEX protocol. I'm going to show you how we can actually tackle that apparent fragility of the internet that we mapped out. And we're going to discover what bips and bobs are pieced together to make up the next generation of scientific publishing. All right, dive site survey. We're going to start the surface, the gateway or the user portal, which is basically the web app as you see it. Click around, drag and drop files, hit publish, upload your scientific manuscripts and presentations and data files and what have you. We're going to zoom down to how this is represented, like serialized. We're going to look at how we find those serialized publications through SIDS. And we're going to look at how the data that you upload to a publication is associated with that manifest. We're going to see how we can fetch that data without running into those issues with the fragile internet. We're going to see how we use something called Ceramic to enable versioning of those IPFS data points. And we're going to see how we can create human-friendly references to tie all of this together. And we're going to see at the absolute bottom of the abyss what CODEX really is. All right, hope you're stoked. Let's go. So possibly familiar for some of the attendees, this is our web app. In CODEX speak, I like to talk about these as gateways. This is like the way the user can like peer in to information on the protocol in a way that makes sense to eyes and people. So it's like a rough overview. This is a publication that's made by a NASA researcher. So basically to the left here, you have your good old like Google Drive style file tree. You have telescope data, you have code to analyze that data, you have a paper, you have other resources like discussion threads on Twitter, you have your abstract, you have like a set of versions of this publication. So this is like the user-facing part of the app. Its purpose is to protect you from basically everything I'm going to run through this seminar. So that's that. The next level, and believe it or not, this thing to the right is the same thing as this. So this is how we serialize the publication. So the structured format that holds all of the same content. And the gateway's purpose is to take this and render it for a human being. So I think the key takeaway here when comparing it to other places where you can like find and consume content on the internet is that this is not stored centrally in our databases. We're not taking the information in a form, stashing it in our like secret hideaway place, and then showing it on demand. Because that's the usual like access method on the web, where an actor can at some point decide not to do that anymore, which is what causes breakage and access issues and all of that stuff. So we've taken the publication, we've broken it down into a serializable form. So here we have like information about the author, the research field, which license you can use the content of the publication. We have something mysterious called the data bucket, which we will get into later. We also have some meta information like file types and paths of PDFs and like keywords for search and descriptions and all of that. So this manifest file, if we are not storing it, or if you can find it through other ways than just like going through us, this is stored on something called IPFS. And the way you refer to things on IPFS, which we will get to, order possibly switched up, who knows? We can think about a SID as a unique identifier for manifests or content in general. They look as lovely as the framed portrait to the right. This is what I mean when I say we've left the realm of human and eye-friendly content rendering. What's cool about this is that this address is completely based on the bits, so like the file contents of the stuff that we target. So when you want to know about this file, you don't ask for it by location, saying like, hey, domain google.com/this path/this file name, I want what you have there. You're basically just saying, hey, I want the thing with this fingerprint. I want the thing that has this content. And this is quite unique because it sounds simple on the surface, but it's really like, at least to me, quite mind-blowing, because it doesn't matter where the file happens to be physically located at a certain point in time. It just needs to be. And this is like an unambiguous way to refer to the same manifest schema that we saw here. So it's basically, it's unique little tag. I just want to like stop and like really drill into like how cool this is, because it's backing basically every single part of the stack. Like with content addressing, so links that are defined by the content of the thing that they target. We can have links that are correct regardless of transfer protocol. So the link is correct whether or not someone like brings it to you by bicycle or if they send it through FTP, for example. The link is correct even if the file is physically moved. So the company that hosted the file has gone bankrupt, but someone else is hosting the file. Your link is still correct. the link is its own validation scheme, because when you actually get the contents, you can run the same check that was made to create the identity, like the identifier to begin with, and verify, like, if that doesn't arrive at the same address, then it's not the same file. And this is really cool, because then you can actually receive content from people you don't necessarily trust. Because if you ask for a specific hash or SID, and you get the file and verify whether or not it's the same, like, if it is the same, then it's the same bytes. You can't stick anything in there, because then that math would not check out. So you have links that can't bamboozle you, and you have links that can't content drifts. Because if the content would have drifted, then it has a new link. So the link you had cannot possibly refer to the same content. The link also can die, which is sort of like half true, I guess. But if the file is unavailable, the link is still correct. The file can cease to exist, but the link is still like pointing to the same content. So if that content reappears, then you can find it with the same link. Unfortunately, they're not very human readable either. So they still look like this. I mentioned we have this special SID, the special little component in the manifest that we looked at. I guess, for lack of a better name, this is called the data bucket. It's a bucket you stick data into. I talked about SIDs previously as files, which is not necessarily true. Kind of it. Okay, almost philosophical. Let's skip that little tangent. But a SID doesn't necessarily refer to a file like a TXT file or like a database dump. It can refer to other structures, like other SIDs. So you can have a SID that points to 3 other SIDs, for example. And this is kind of what the data bucket is. Inside the manifest, you have a SID that's pointing to a collection of other stuff of arbitrary sort and kind. So that stuff could in practice be like a PowerPoint presentation and a gigantic data set and a shared script or a picture of me or you. So SIDs can also identify like generic data structures built from other content address things. Yeah, and if you change any of those things in that structure, then the SID is not the same. So the same guarantees we had for accessing one file applies to entire like collections of files. So tasty water. One particular sort of collections you can, or like the way you express collections of stuff in this way is called IPLD, which stands for the Interplanetary Linked Data Protocol, which is very grandiose. But you can think of it as a way of building tree structures. And some of us like and enjoy tree structures on a regular basis. Some might not be as familiar with them. But it's basically anything with a root with like a bunch of content underneath. A good way of thinking about it is the file system on your computer or in Google Drive. So basically you have one root folder, like the C drive on your computer, which contains like a set of directories. And in those directories, you can have more directories or files or nothing. So one such implementation or one such standard built on IPLD is Unix FS, which stands for the Unix file system. And this is what we use by default as the root of the data bucket in the publication. So it's basically your good old file drive, sort of. It's not limited to this, but it's the default because it makes a lot of sense most of the time. I get that this is abstract, but we do have examples. Okay, this is even more confusing. Let's hide away again. No, but when we talk about file trees and file systems, mentally we can think about it as the computer. And even if the SID, sorry, looks like this, just like one long string thing. If we look up that SID, and this is a tool called IPLD Explorer, aka my best friend. So we can basically input the SID here. You can see that it's actually a different SID if you're super observant. But basically this SID points to a UnixFS file system, or is something that, yeah, basically maps to a drive on your computer. So you basically have like a list of files. They have file names, and you can see each file name is its own SID. So you have this like it's just SIDs like from the bottom up to a root. And to the right here we have a little visualization of that. So you have information about the SID, and you can see the SID just points to 5 more SIDs. And all of those could be files, could be directories. So it's just like recursive all the way down. So what's mind-blowing about this is that you can stick an infinite, okay, that's a big number, but a very, very large set of data of like arbitrary shape, and basically boil it down to a single 64 character long string, and have that uniquely identify literally everything inside. The theory behind this is called like Merkle trees, if you want to look that up. If you don't, that's entirely understandable as well. But yeah, the key takeaway is basically we have a way to reference all of the data inside of the publication without having to have the data there. We just need that little string. And if anything changes, the SID is not the same because it builds on all of its children. Hope that's clear. By the way, I cannot see the chat, so feel free to just like jump in and shout out if you have any questions. I'm not ignoring you on purpose. I am ignoring you by accident.
But Edvard, could I ask, it's Francis here, sorry to jump in.
Yeah, sure, go ahead.
But things change in life. So what happens when something changes? Does that disrupt the whole system?
That's an excellent question, and a large part of the topic. I promise you we will get to it.
Okay, thank you.
Yes, it's a good observation. So this brings us to, maybe you've heard about IPFS. I've heard many confusing explanations about what IPFS actually is. It stands for the Interplanetary File System, but it's not really a file system, which is confusing already there. But in a nutshell, it's basically if you communicate peer-to-peer, i.e. without a central server, about content expressed in IPLD, that's sort of what IPFS is. So talking about these like hash-based data structures and exchanging them with one another without a central server. Kind of like touched on these a bit, I guess, but we query content by fingerprint, not by location. And it's trustless in nature because you asked for the content by its fingerprint, and you can verify that that's correct when you get the file. It's uncensorable, it's highly available, and you're not relying on any like large company or service to like continue to serve the data out of just goodwill. We can do this as a network. As a practical example, let's look at this through the lens of tomatoes and potatoes. Found this very cute visualization earlier today, but it kind of visualizes how this going, how it's working. So let's say we're looking for the manifest that is represented by the tomato. Instead of asking a particular server where that is, we say to the network like, hey, we are looking for the tomato. Other nodes in the network can listen to these requests, and this guy doesn't have anything, but he can relay information about these two nodes, one which has a tomato, one which has a tomato and a potato. So this is the way we do like content discovery or like content routing, I guess. define the manifests without necessarily getting them served from us or some other like data host. All right, like someone accurately pointed out, we've just built ourselves a problem. Now everything is hashes, and we have no idea what hash is what. How do you know that this Buffkregel is the new version of the paper at Buffkregel? This does not make any sense. And how could you like possibly know if you're interested in one of these or not? Like there is no context here. You need to already have the information to know what you're looking for, which makes it very dysfunctional in terms of content discovery. So we need some sort of contextual layer for versioning and navigation. Let's start with versioning. This is sort of the question that just popped up. How do we update stuff? If everything is uniquely identified by its current state, and if you change anything, then the link is not the same, how can you update something? So the problem we want to solve is basically up to the right here. You hit the URL that right now leads you to paper.pdf. At some point in time earlier, it led to another file called paper.pdf, which could have been the same, could have been a different one, or it might not exist. But the issue here is that you have no idea about the history. You have no idea about the historical lineage. You have no guarantees, basically, on the content that you're getting, and you don't have, there's no structure to it. So this is where we use something called ceramic or ceramic network. So each publication is created as what's called a ceramic stream. This allows us to like have historical transparency. So if we look at the other example here at the bottom, each stream gets a unique identifier. So like the stream itself is called XYZ. And this stream uniquely identifies a series of updates or events, commits called sometimes. So we have a stable persistent identifier for something that's cryptographically like chaining together a set of updates. So we can use this to version content addressed information without losing any of the guarantees. Key here is that the author, so the one who made the publication, is the only one that has access to update the stream, and that is what the network part of Ceramic Network does, basically validate updates and correctness of signatures. So I created XYZ, only me can add a new version of XYZ. But if I change something in XYZ, you as an observer can see that this has changed, and you can see the previous versions, and you can look at like the changes between those. And what's key here is that this allows us to do it without relying on the end user interacting with the smart contracts. So previously, that was the model the publishing process was built on, but there is a lot of UX problems related to like gas and signing transactions and managing keys, and you have tokens, and like how do you get tokens for gas? And it's just like everyone that's familiar with the Web3 space probably has been confused about this a bunch of times. Yeah, so basically we tie all of these updates together with a new type of identifier that can span time. So before we have, so we can call V0 here the manifest or the manifest SID, which inside had a link to a data tree. But then you publish a second version, but there is no way as an outside observer to know that these two are related. So what we get to see is this instead. So these data trees, we have a way of like figuring out how they've changed over time. And this little event, like creating one of these, is what we call publishing or like updating a publication in the app. So basically tossing on a new event on the little chain that represents your scientific work. All right. So what we've done here is we've solved the versioning part. We had one more issue, which is discovery. So great, now we don't have like random CIDs, but now we have random stream identifiers. And we basically have the same issue still. So like, how do we know that this new stream that just popped up is interesting to me? How do we know the context around it? How do we know if it relates to any other information that's published on the protocol? And this is where CODEX comes in. It's basically a way for us to define a graph of scientific contributions, like draw relations between publications. As like a vague example here, we can say like each of these nodes in the graph to the right is a publication, and each edge is a citation. So basically you can, starting from one of these publications, you could see like, ooh, these other publications are related to this one through citation. I'll like check those out, and then you can like continue going in a recursive fashion. So if we have different types of nodes for different types of contributions to science in this graph, we can explore that data set in a quite unique way. So like search for publications by author or by the data sets they reference. Say you have like a favorite author and you want to find all of their papers, and you want to programmatically download all of the data that they've used to come up with those results. There is no way of doing that in a simple way that doesn't look like a private investigator practice, the way science is published today. So building up a unified universe of scientific artifacts, their publications and relations to authors and stuff like that, that is the goal of CODEX. So how does it solve discovery then? So these streams that are created, they follow a certain schema. So basically what CODEX is a set of such schemas that we think will define the core of the scientific literature, or like the tree of science in some sense. One of those is the research object, which is just another word for what I've been calling publication. It's just a versioned piece of scientific publication. Yeah. So arbitrary data artifacts and manifests and PDFs and author info and all of that stuff. So what's cool about using Ceramic for this is that when you index content, you index it by schema. So if you say, I want to know which streams implement research object, or in other words, which streams are scientific publications, it can answer that for you. So now we have a way of querying for certain types of contributions. So you want to say, oh, what's published? And then the index can reply, oh, A and B are new today, for example. So what do you get when you combine this with other data types? So now we have one for the publication, but what if we want to add more stuff to it? So another like simplified example, but your most like fundamental identity is some sort of cryptographic key. It's called a DID, or decentralized identity. So here we have two people that have done stuff on the scientific graph. So DID1, pseudonymous, but it has an associated user profile. So we know it's Professor Fig. We know that because we can query streams implementing the profile schema or the profile model and see that there is one linked to DID1. And in the same way, we can discover research objects. So if we query both these models by this DID, we can find all of the instances that this identity has created in the graph. We have another, this opponent or friend. It's not clear. Dr. Date also made a publication, and we throw a third type of model in the mix, so an attestation or some sort of claim about quality. So we see that Dr. Date has perhaps done a peer review on research objects that Professor Fig created and decided to award a golden star to version 0 of that research object. And when you zoom out like this is really where the expressiveness of having science as a graph becomes clear, at least to me. I don't know if it's clear to anyone else yet, but we can express so much and in such a way that it's dynamically like explorable and discoverable. And we have a hand. Logan raised a hand.
So you said that the star would be awarded to version 0. Does that have any representation on version 1, version 2, etc.? Or is it simply just glued to that version 0?
Good question. I would say it's probably depends on the type of attestation. Maybe the level of detail there. I don't know if it's good or bad right now, but let's go with it. So the idea is basically, since you have the possibility of tracing like verifiable history, it's really practical to know exactly at what state something was said about something. So I thought your paper was solid and you had the data available, and that was at version V0 or version 1.
So maybe the star remains, but has some indication of when it was awarded to what version.
Exactly. So basically, what you want is to be able to go to research object 1 or this publication, whatever it is, and see, it got a star from Dr. Date, and you have high credibility in this science community. So that's good for you. But if you you change something, or like you cover up a bluff, or I don't know, something less dramatic possibly, it's just good to know what changed between. So like, say you remove the data set, and then Dr. Date here looks a little bit silly for saying you are great at publishing data with your papers, but there is no data there. It's good to have that like historical verifiability. But what I mean when I say it depends on the attestation, or depends on the award or badge, or whatever you want to call them, it's basically, for some types it might make sense to have it like consider it more or less permanent. For some types it might only be relevant for a specific version. So let's say like if this constitutes a peer review receipt, for example, I haven't peer reviewed version 1, I've only peer reviewed version 0. But I guess it's like up to the observer to some extent whether or not it still applies. It depends on what's changed, sort of. But if those changes are like, fixed all the complaints from the review, then maybe Dr. Date comes around and approves that, or like validates that the changes are like indeed
Thank you.
sorted out. Good question. Thanks.
But Edvard, could I ask who generates that star? How is it generated?
So that's also a very good question. So key here is that the only one that can generate content that's associated with your identity in the protocol is you. So even if the attestation has been created by, or like, there might be like ready-made or like community attestations, like I think this is good, or stuff that's like more specific, like this got funding from the US government. It kind of depends on who made the attestation, whether or not it has any weight. So there is like complexity here around like different types of attestations, and like some can only be like given out by the one that created it, and some might be generic. So we can say like, here's an attestation anyone can give to anyone. So we refer to these as like protected and unprotected attestations. But you can think about it as, in terms of templates and like instances as well. So you can have like, yeah, like, is the attestation the act of putting the name on the like pre-printed contracts, or is the contract itself the attestation, if that makes sense?
So what I understand is you're trying to do two things. You try to create a new knowledge system through your knowledge graph. I would call it, say, something like a digital Dewey Decimal System. So you're reorganizing knowledge according to relationships to one another. And then the second thing you want to do is make an evaluation of those knowledge objects. Is that correct?
Yes, and sort of, I guess. Like, the protocol doesn't necessarily, like, at least like my personal vision for this is that, can we have a common backbone of where you collect the raw materials from scientific publications and related artifacts, and use that as the target for other types of contributions to science that depend on that information? So the ordering of like manifests and versioning and having this like stable resolution scheme over changes to publications is really core. This demonstrates like how you can use that as a basis for saying other things about it. So the protocol has generic ways of talking about attestations, but it's really up to like the community and like what ends up being useful statements to say about science. Like, I think this is correct, I think this is bogus, for example. That might be practical. So it's more of a like a way of expressing comments like that on a source that is like known to be true and stable and persistently resolvable. John, and
we can't really hear you.
indeed we cannot.
Okay, maybe you can go on. He just wrote in chat that he'll fix his mic and come back.
Could
Alrighty.
I wanted to hear John first, actually, on this, but Edvard, just to be more difficult, it seems like you want to create, which I think we need to reorder knowledge and reorder how we understand knowledge. I agree with that. We're past the 17th century somewhere now. But what I see you doing is making this very personal and subjective. Like, this is my knowledge, this is my paper, these are the links to my stuff. And Edward's my friend, and I'll send them a lot of stars, and Logan, I'll just send them a lot of hate. And so we can play that game, but so there's two aspects of knowledge that I think are important. One is the relational, and I think you get that with your knowledge map, which is what we need. But the other aspect of knowledge that's important is it real? In other words, are we saying things that are true? And it's not just because Logan gave me a star today, and I appreciate that, but it's because something that I said was actually true, which I would like to also report to my children at a certain point. So, thank you, Logan. So how can we get away from this very subjective kind of thing? And what I'm thinking of is how can the system itself appropriate attestations? Why can't we have rely on, to a certain extent anyway, on machines to do this as well?
Apt observation. And the way I absolutely get your perspective. And I mean, like the example of the golden star from a friend is, you know, a little bit made up to make this example simple. But okay, I guess I have like a two-tiered answer to this. One would be that this is basically a representation of how the peer review process works today, or it's a way of documenting an instance of peer review. It could be. So that's like the traditional way. But exactly like you're saying, like if we have the ability on a research publication to also associate with the paper an arbitrary data storage, which could contain your analysis scripts, the data set that you use to come up to the conclusions that you have in your paper. Basically all of the like bits and bobs, like Docker containers to run it, Jupyter notebooks, basically anything you need. Anything that's data and serializable, you can stick in there. So it's entirely possible for you to build a publication that is machine actionable and like automatically verifiable by correctness. But I think in the nature of like computing, like not all results are always going to be like deterministic. And I'm not personally convinced that this is like a valid approach for all types of research either. But it's a really cool ideal. And I think a prerequisite for that to function is to have ways of persistently resolving information related to the publication to be able to manually or through automation claim any sort of correctness. Because if you can't find the data, or if you can't trust that it was actually the same data that the author used for their paper, that problem becomes much harder. I guess is kind of my thoughts on that, but it's a very good question.
Cool, and I think
Does my mic
John's
work
back.
now?
Yeah.
Woohoo! I am super curious how we're using or how we're handling schemas with all these different artifacts. So we've got like a manuscript, which has different attributes than a data set, which is different attributes than a set of software. How are we merging all of these into one schema or database, or how are we handling that, if this makes sense at all?
That is a good question. And it's also the next slide.
Woo!
What a good segue.
Okay, since we're going to that segue, I'll add to that question. How do we handle the addition of new attributes and data points that are undoubtedly going to be added in like 10 years once we have a different artifact that's related to research, and we have to change the schema going back another 50 years, like modify everything?
Yep. Good question. So when we talk about these schemas, some things are like more general than others. So say like the data bucket thing is like an identifier of an arbitrary bunch of data. That's like, you can stick new file formats in there. You can like use new types of, data serialization, like that's already like very generic. But say like the profile, what if Twitter isn't a thing in a while, and like Orchid or Google Scholar, or I guess this is where you're getting at, like We can't snapshot our current understanding of what's important and just assume that's always going to work. So I absolutely agree with that. I want to clarify something, which is when we talk about all of these different models, it's easy to think about them as like one schema to like represent all of these things. But the thing that we use to like index all of the ceramic streams is called ComposeDB. And the solution is sort of in the name a little bit, that we're not strictly following a single schema that defines what can and can't exist. We are using a composite, so like a collection of models or schemas that you happen to care about. So maybe this example will clear it out. Maybe it won't answer all of it, but I think we will be in a better spot to discuss that after we go through it. So what's cool about having, like, looking at the content of this graph, or like all of the entities that are created in the protocol, or like all of these loose streams or whatever you want to call them, is that we choose which models we want to index. So what do we care about? Maybe you'd never care about profiles or attestations. You just want like raw data sets. Like, you can build a gateway that just ignores the rest. You can just index raw information published and do something cool with that. You can also like use it as a stepping stone to implement completely new things that uses it as the source. So let's say, okay, our way of like storing scientific contents is so outdated. Everything is LLMs now. We need AI analysis to understand anything. So let's say we want to like, oh, why didn't we stick LLM embeddings in the schema? Damn, we missed the opportunity. And what's so cool when indexing is based on these like composite expressions about schemas is that you can add stuff without having to govern the process of doing that. So the protocol is more meant to be like this small, stable core that you can extend with new types of composites. So in this practical example, let's say project XYZ wants to create semantic embeddings or LLM/AI stuff, for the ones who aren't familiar with the term, for all scientific publications, or just the ones they care about. They can create a new model or a new schema and start querying for research objects, finding research object A, dig through that data, create semantic embeddings for that content. And this schema contains like a reference to a research object model. So basically you have a like an A encoding that is an implementation of the LLM embedding model, and it has a like reference to A, an instance of a research object. Right now, without telling anyone about this, it's probably not very visible. But people or organizations or communities or whatever it might be that are interested in information can just say, okay, I want to add LLM embeddings to my CODEX composite, or like the filter stream selection filter. And now you can view this as one like unified data set. And there is no difference between doing this and whether or not this had been like already pre-implemented when the research object model schema was created initially. So stuff can like plug and play, and we can use these unique identifiers to the individual streams as references. And this will become a new type of node in the graph analogy. So basically you can say like, query all of the research objects that have LLM embeddings. And the same kind of thinking, like modular thinking, applies to, like, I guess more or less whatever you want to put in this graph. And what's so cool about that is that it doesn't really matter if you put bullshit in there, because if I don't care about that content, I will just not index models that, like, maybe I'm not interested in semantic embeddings, then I can just ignore this. We can coexist. This can work for ones that find like huge interest and like usefulness in this, but you don't need to like opt in to using that information in the graph. So I don't know if the like
So
does it
Edward, could I ask
sort
you?
of answer your question, John?
Yes, it does. And it sounds really interesting. It sounds like there's the potential for like a marketplace of model builders, which is a critical aspect to research.
Yeah.
So neat. More modularity.
Nice.
So Edward, as Ellie knows, I really like hippies. I admire them enormously. I wish I could become one someday. But I do have a problem, not a problem, but a question, I guess. So do you need an ontology, or is this an index that needs no ontology?
Great question. It probably needs an ontology, but it doesn't presume one. I would say like being metadata format agnostic is one of the core like design principles. We saw there was a schema for the publication in the research object model. That's basically the old version of the protocol that we just have in there. And the idea is to fork that out into like other smaller fragments of metadata as parts of the graph instead of being. So basically the problem you want to avoid is if the authors choose to use this particular type of ontology, then you can't like get another one without convincing them to go back and like update their publication. So if you actually split this out, it's entirely possible to have like parsers or like bots going through new research objects and like taking the metadata and converting it from shape A to shape B, and creating a new node in the graph related to that. So you can go to like research object B, and you can like see what shapes of metadata have people attached to this. So like there really isn't any like formal bounds, like there's not really a formal limit to the expressiveness here. So if there is like a standard that makes a ton of sense that a lot of people think should be present around a scientific publication, then that sounds like an excellent idea for a like metadata sidecar sort of.
So there was a time before anybody here was born when I used to take students, first year university students, to the library and say, if you want to find out something about this topic, this is how the library is organized. And so you can go to this section of the library and you can find that information, that set of publications, as it was, actually on stacks. How do we find our way through your library? So when I take, or when you take your first university year students to this library you're presenting here, how do they find their way through it? Because where is where are the signs? Where are the pathways? How do they know if they're interested in physics, where they can find out that stuff about stardust or something like that?
Again, a great question and a solid observation. So at the start of this little dive of ours, we had the gateway. The one that we built, so DeSci nodes, is sort of like our opinionated perspective on this graph. And a way, like in the same way that like a newspaper chooses what information about the world to publish, you can have like different perspectives on what is useful information and like what you care about.
But that's exactly the difference between a newspaper's publication on the world and a scientific publication on the world. Because science has been, I'm sorry, I'm very old, but science has been considered like an organized body of knowledge that's interrelated and doesn't depend upon individual personalities. I mean, that's the way it's presented. I'm not sure it's ever been that way, but that's the way it's been presented. But you seem to have a highly individualized personal approach, which does work well on Twitter, or it works well for the New York Times, or the Guardian, whatever, Le Monde. But does it work here? Does it work for science?
I'm going to pause that conversation and maybe keep, like, Edward has a little bit more to get to, and then we can maybe dig into that afterwards because people are dropping off.
Right, that sounds good. Let's do that. All right, next step. We have a graph that we can use to locate and explore scientific publications. But we still have a bit of a UX problem. So the identifiers are still like long, confusing strings, even though those long, confusing strings can be discovered. But we don't have a good, like, human-friendly way of referring to them or referring to content. So the idea here is that how do you like create a link to the PowerPoint slide that you had in version 4 of your publication? We've sort of solved the technical challenges for doing this. You know, we have like some sort of root hash that's like provably done by the author, and we have this metadata, we have this root data container, and then we have some sort of file structure. So what we call DPID, or decentralized persistent identifiers, is a way of making like more human-friendly links to content running like that's published on the protocol. And it's sort of two things. It's an alias, or a human-friendly link. So basically a PID that's not a long hash. So say the number 123, but it's also a schema and a method for referencing content inside the publications. So my favorite way of visualizing what a dpid is this red squiggly line. So it's basically a way of like finding a root node of something you care about, which would be like 123/version 4, and a structured way of navigating within the file tree. So all of the artifacts inside there. Sounds complicated, possibly, but we can do it on paper, basically. So let's resolve a DPID. So say you want someone posted, or it was written in the references section of a paper you read, or it's trending on science Twitter, or we found it in the library. You want to have version 4 of DPID 123. So basically, the resolver is an application that's like open source. You can run it yourself. It basically goes to a contract where you have this alias. So where 123 is defined to point to a stream. So it goes there and say, ooh, looking for 123, cool. Goes there, find a stream. Looks like this. Then it loads that stream and checks that sequence of commits related to it, jumps 3 times to find version 4. Inside that commit, you have the manifest SID, so the little like data schema that we render in our app, or you view in JSON because you're a JSON aficionado. And then the resolver sends you the SID or the file directly, whatever you want. And you basically do as you please with this. Probably as a normal person, use some sort of viewer that can render it, like showing PDFs and allow you to like browse around through the files. So it's not that bad, at least in my opinion. Not too shabby. A little FAQ section. So what does all of this like cost? Does it have a cost? And the answer is no. This is like free and open public infrastructure. In fact, we can't even stop you if we wanted to, which is a feature and a bug. As for the services that we like host and like serve as web apps, our gateway is like free to use. We offer very generous like free storage for your staging files, so unpublished content. And everything we write and release, almost everything, I'm not gonna like make promises here, but everything I know about is either MIT or a GPL license, which basically means if we are not being nice, then fork the software and like do it better. There is no like hiding behind vendor lock-in or those types of structures. Also, like, why a new type of identifier? I might just want a DOI. DOI is for those not familiar, the permalink of science. But quite recent meta studies about science show that the stats about how many DOIs that actually function and actually have content drifts, they do not look very healthy at all. So unfortunately, this doesn't solve the problem. So the way it works is basically you sign up for a DOI and you say, I want it to point to my homepage. But then if you move your homepage or your server crashes or you switch hosting providers or switch domain, then you need to go to DOI and update that. And if you don't do that, then that link is still gonna permanently point to a thing that no longer is your content. And if you do like add 2 things up here, you can have a DOI and point it to content that's persistently available through CODEX. And now you have an enhanced DOI. So it's not really like a rivaling technology. It's just like a different way of storing and referencing the content. So yeah, the DOI sort of like inherits the guarantees that you get. We can actually already do this in the app. So when you like make a publication package, we can mint a DOI for you. So that's kind of 0 work. Also popular question, can I run this on my server? This is more complicated, not in practice, but like there's a lot of ways of interpreting this question. But I think mostly yes. So you can create publications and DPIDs from your computer without having to like run a service or like have something continually running, because it's using open public infrastructure, like Ceramic Network and blockchains for the DPIDs and stuff like that. You can run a public resolver if you want. You can self-host your manifest files. You can self-host all of your data. You can write your own gateway, run that using all of the other jazz as the like backing storage. And you can extend CODEX like we saw as well, which also kind of requires you to run a node, I guess, initially for that to kind of bootstrap. But yeah, as far as like backend services and like our web app, we would like this to be easy. But that part of the stack, so like the more like user-facing apps and our like, production backends, is like fairly complex. All the code is out there, but I would say mostly no if you don't have plenty dedication. But this is somewhere we want to improve. So sorta, yes. Can I run this by myself? Depends on which part. Can you mint DPIDs for local content? Yes, you can. Since we saw the SID, it's just a string. Like the actual data isn't inside of the manifests, which mean you can it's like create a SID that has a link to content that we do not have or no one else has. So the link is still correct, and if I get the data, I can prove that it's what you link to. But it's not like, yeah, it doesn't leave your machine basically. And sort of along the same lines, can you restrict access to data? Yes, you can, because because the SID is there doesn't mean the data is necessarily there. So you can publish and link the data to identify what data you used, but you can have an arbitrary gate for access, whether that's automatic or if it's calling you on your phone and asking for it. Protocol really doesn't mind. And is anyone using this? And yes, they are. So we have multiple communities that work together to like curate publications on the platform, which can sort of be likened to like running a journal, which is a use case that we're looking into. And we have a like steady stream of users. So we're already like the protocol is already like hosting 20 terabytes of data and a bunch of open access articles. We're working on, or we have ways of bridging to traditional scientific indexes as well. So you can like view data not published on nodes initially, sort of, as well. We've issued a bunch of persistent identifiers, and yeah, it's quite proven and it's growing quite fast. And I think the last one, what about crypto wallets and gas fees and slow transactions and all of the nasty stuff from Web3? So if you start with wallets, you can bring your own wallet. Power users, whatever that is, might want to, might not. Otherwise, we can generate one for you using like, it feels like single sign-on with Orchid, which is like single sign-on for science is probably my best explanation. So we kind of like, it's possible to hide cryptographic key management in a safe way nowadays. This is not, I don't have a super solid grasp on this part. So then gas fees, since we moved off chain to ceramic, there are no contract calls. So there are no waiting for transactions. There are no gas fees. There are no like token balances you need to maintain for it to function. The DPID contract is super simple and very cheap to run. So it's also unpermissioned to mint DPIDs. So we just do it for free for the user if they want the DPID, but they can also like do it themselves or ask someone else to do it. So it doesn't really break the user experience. If that makes sense. So slow transactions, rather no transactions. And with that, I am done. And I do not have a watch, so I have no idea if I'm way over time, but I would assume I am.
It is 12:15.
Nice.
But there was
Good
lots
estimate.
of discussion in the middle.
Indeed.
I want to give people like the freedom to jump off if they need to, but if there's any other questions, also Edvard, do you have any moments to take questions, or do we need to just head off?
For a bit, that's fine.
Yeah.
Can I give voice to Francis's question here with a little more context? I'll just do it.
Sure.
He asked, why would someone use this rather than Zenodo for your publications? And I'd just expand that to why use this rather than any of the current infrastructure out there? How does this differ from things like Zenodo, a publishing house, something like OpenAlex even, as a library of knowledge?
That is a good question. I can I can speculate, but honestly, I don't have a super good grasp on exactly how that works. But the fundamental principles that all of this relies on is basically standardized ways of resolving information in a way that literally cannot break by any like actor or hosting provider or CDN or search engine going broke or becoming not nice. So that's sort of the core principle that we think is necessary for something like this to function over a very long period of time. It needs to be independent from us continuing to exist, because ideally this lasts longer than any like individual company or person, and that is a tricky time frame to work with. That's probably the best answer I can give.
Cool. Logan? Or John, do you have a follow-up to that?
Nope, different question. Logan's first.
Okay.
Has there been any further consideration on the proposal I made way earlier in this year, or consideration or work even, regarding the local installation of nodes to user computers that reserves some space to allow for automatic backups of files to create a stronger network and accessibility of these files?
Just rephrase so I understand. Basically, like a way of like hopping on and helping secure.
So way early in this year, like in February, when I was first talking with all of you about this, I had made a proposal that with a local installation of nodes for users' computers, just like a desktop installation of it for easy access, that it could reserve some small amount of storage on the user's computer, like 10 gigabytes or something, that could then be used as an automatic repository for files that have been uploaded into the nodes system. And that would allow for a resilience of the data, that if the original author deleted it, it's not suddenly gone if they were the only host of it.
Yeah, for sure. I getcha. So there's like two layers of looking at this. One layer is like the metadata layer and like the navigational layer. So like the content of the manifest and like the metadata about the publication and the content of the streams. So like which publications exist, what data do they have associated with them, but not the actual data structures inside. So that part, the light part, we can call it, that's more or less starting a ceramic node and indexing the schemas that are used for this model, like indexing the models that are used to represent published science. So that part is easier. As far as actual data resilience, that is way trickier. And basically all of these like large decentralized storage networks, like, you know, Arweave, Filecoin, they've tried to find ways to financially incentivize long-term storage. But I've toyed with, I think it was last ETH Denver, so also around like February, I had a workshop on SciOS in Denver around exactly this, like what pieces of the puzzle do we need to have in place for something like that to work. So basically, I know John really doesn't like when I compare it to folding at home, but sort of the same thing. So like, hey, I just want to like donate some of my resources to like help this larger thing. I would really like to see that as well. I've thought about how that could work, but I do not know how practically feasible it is from the nature of how IPFS and like indexing, and yeah, it's a really cool problem that I would love to work on.
Okay, so
the
there's been
short answer
consideration,
is no.
but
yeah,
okay, no further work into it yet.
yeah, I think it's it might be a very large task, but it's a problem that I would love to see solved for sure.
Thank you.
John, comments about folding at home?
So, no, not this time. I do think it should exist. And for the record, it's just the naming of it. Folding at home has a history. You can't just take the at home, man. Okay. So actually on that, Logan, library, we succeeded in that. It was the largest distributed storage network for a long time until it got shut down by the SEC. It was very successful. It's very similar to it was similar to what Labs was building for a long time. It's probably differentiated quite a bit at this point. But it worked very well. There was no need for incentives. People stored content like crazy for free. My question though, right. I'm very excited to use this for software. And this kind of goes to, Francis, your question about why would you use this instead of Zenodo. There's currently no way to upload software and get credit for it, to the extent that people had to create their own journal to exist within the legacy system, where someone could submit just like kind of a BS paper on research software to get citations for that software. And then every time they publish a new version of the software, they have to create a new manuscript to get citations for that new version. There's no versionability in any of that. So I'm sure there's many other people with similar experiences with different types of scientific assets like data. How can we start building on this? Do I just start uploading software repositories as nodes? And I think this is a deeper question and ultimately a comment that I can't phrase as a question because I'm just really excited about what this thing is. So apologies if there's nothing to actually end it there.
It made me think about another answer to the Zenodo thing that I had planned to go through, but time and stuff. Again, I don't really know like how Zenodo actually works, but what I find really cool about CODEX and the way we built things is that you have programmatic interaction with basically every part of the stack. So it's entirely possible to make a research publication that's like listening to an RSS feed, and every time you get like a new message, it will publish, add that to your node and publish it. So you can like programmatically make publications or like research publications that analyze like live data. So you can have like a weather model, and you can include like, it's like you can make sure that the weather data inside that you can like run the notebook on is like from today, and doing like interactive stuff and like automated stuff around scientific publishing, both in what was mentioned earlier in like validation of results. Like if you have computational verifiability, you can like bot that and like say, yeah, this passes, like this math checks out. I can reproduce these results with computation, or make like interactive nodes through the programmatic like level of it. I think that's really cool. That's absolutely a tangent, but worth pointing out.
Nice. Thank you so much. I think we'll end it here and we can maybe follow up on some of the discussions that we started. But this was super lovely to dig into, and thank you for taking all the extra time as well for everyone who's here and still here.
The trick is not knowing what the time is.
Fair enough.
And as a last word, feel free to hit me up on the DeSci Labs Discord or Telegram or like, I don't know, GitHub if that's useful. But yeah, happy to chat about this stuff for sure. And yeah, thanks for
happy to
listening
connect you.
first and foremost.
Yeah.
Thank you.
Thanks everybody. Bye.
Yep. Thank you.
Thank you both.